Hello, everyone. So I'm Mark Ledwich. I'm not a academic. My background is in business intelligence software, both on making it and being a consumer of it. And this is kind of my hobby. And I worked with Anna Zaitsev, who's at Berkeley. The paper that we wrote's got some attention, but I'm just going to throw all the technical details before I get into the wider picture. So we've been extremely focused just on this narrow feature of YouTube, the recommendations. So when you watch a video, you'll see on the right, if you're on desktop, beneath, if you're on mobile, a list of videos that it's recommending. And the very one on the top, that will autoplay next by default, unless you turn off the autoplay feature, and the rest are just presented to you. It's seemingly fairly innocuous, but I think it's actually quite an important, has a big effect in terms of beliefs. So Google, through search and YouTube, has a lot of soft power. I don't think they sought out that, but that's what they have. So they can influence people's beliefs quite easily and in a way that is hard to detect. So for YouTube in particular, 18% of US adults, according to Pew, watch YouTube for at least part of their news diet, and 70% of the watch time on YouTube is from their recommendations. That was just one marketing person from Google back when they were boasting about this kind of thing. But if it's anywhere near that, that's still a lot. The other aspect to this is Google is not transparent at all about the recommendations or the way the algorithm works in detail. Their transparency reports are just more like marketing documents. So they contain top-level numbers showing, trying to present how well they've been working on those things. And I think the media is often hostile and irrationally so towards tech now. So in that environment, it makes sense that all the communication is very strategic, contain very little information that they can be called out on. So they don't share things like the aggregate statistics on recommendations that they've shown to people. And for creators on YouTube, there's a lot of decisions that get made that everyone else just finds out when they happen. So for people making a living, it can be difficult working on YouTube if you get copyright strikes, your videos get demonetized or the video gets removed. And it's very much like the weather. You don't always know why it happens. And it's quite hard to predict given how frequently they change the rules. It's definitely in the public interest to understand what Google's influence on politics is. There's historically always been a really keen interest on fairness in media coverage of politics. So in the US, there was the Fairness Doctrine, which was an attempt to regulate ballots and the variety of views that get aired on controversial topics. In Australia, we have rules about equal coverage to candidates and media ownership. But none of these approaches seem very relevant today, given the internet. And I think we should be skeptical about the practicalities of government regulation working in practice. So I think it's definitely an important role of researchers and journalists to discover and report on the impact that YouTube has and any massive content platforms. And then an informed public can pressure YouTube to change for the better. I don't think that's naive. They seem to be reacting and responding to public pressure. But there's problems with, I think, researching journalists in this area, which we'll come back to at the end. So here's a bit of technical details about how we collected YouTube data. I've got an Azure function, which is just a little program that runs in the cloud. And the advantage is that you just pay for the time that it runs, and it can be triggered based on things that happen. or just on a schedule. So that's the way I'm using it. And it launches a bunch of container instances, which are basically like lightweight virtual machines designed just for a single application with its dependencies. And that launches about 10 seconds. And there's 11 of them. And sorry, yeah, there's 11 of them. I just pay for the time that those run. They read from the YouTube API for channel details, and it scrapes the YouTube website to get video statistics and recommendations. And then it stores all that data on Azure Blob Storage, which is basically like a file system in the cloud. Most people use AWS for these. So if you're using AWS, the equivalent would be a Lambda function, launching Fargate containers and then storing in S3. Then once we've collected the data, the next step is transforming it for analysis. I use Dataform for this. So I guess all of this is an alternative to what most academics would use, is like an R or a Python script. Dataform, it runs SQL in a warehouse. And what it adds just from doing that manually is it understands the dependencies between them. So I can create quite a complicated series of steps, and it understands the dependencies between them and runs them in parallel in the right order. And it all executes in the warehouse. And there's some really good technology. Google has BigQuery and I use Snowflake. Both of them are really good at executing this at scale. And you just pay for your compute and the storage for those queries that you run. So it ends up being cheap, or you can manage how cheap it is by the way you run it. After that runs, I use an R script and C# scripts. The R script is to perform statistical models, and my C# script just gets final aggregated results, which are then used for the visualizations. I use Flow, which is, it's a tool that lets you query the database using the power of the database to quickly build analysis and visualization. And the website, which I'll show you later, that's built using Gatsby, which builds a static website. And the advantage of a static website is that you can host it in a lot of different places and it runs very fast. So in my case, I'm using Azure static websites, and it's distributed using Cloudflare. So when you load up our website, it will be cached somewhere near your city. And there's no like web servers running code. It's all done in the browser. For the code on the website, I'm using TypeScript, which is like JavaScript, but it's better compile time checking when you're writing it, and you get nice documentation in IntelliSense. React, which is a really popular way to do interactive interfaces, all run from the client side. And D3, which is, it's a visualization library, but it's really low level. So if you're going for really polished and particular ways of presenting, like more specialized ways of presenting, you really need to go down to that low level to get exactly what you want. So in terms of data collection, it's not as easy as it should be. YouTube definitely doesn't help very much with this. So their API, we get channel stats, but for everything else, we're actually scraping the website. They provide this information through the API, and that's the way we started this. So from November last year to October this year, we were using the YouTube API, but YouTube actually blocked our access because they restrict, as part of their agreement, that you don't store this data for longer than 30 days and you don't use more than one key. So we needed both of those things. So there was no way around it. When we scrape the YouTube website, within about 50 to 400 requests, we'll get blocked. And to get around that, we fall back to using a residential proxy service, which basically has home IP addresses. So going through Comcast or AT&T, those residential style connections. And that means that YouTube can't block all of them. So as soon as they block it, we fall back to the next one. And there's millions of them. So it costs us, but we can always get as much data as we want going through that technique. And because we're collecting data every day and we're trying to get a lot to have a good representation about recommendations over time, if we did requests in serial, we probably wouldn't even get enough data if it ran all day. But it's a very simple problem to make parallel. So we launched lots of different command line tools in the cloud, like contain instances, which then inside them run a lot in parallel. And depending on what language you use, they usually all have this concept of tasks. That's what they're called in C#. In Node, they're called promises, and Python, I think they're called futures. And that allows you to do lots of requests in parallel without creating a thread for each one, which will make it a lot slower. And usually you need to use a library on top of those to manage a whole collection of things to run. In C#, I use .NET TPL data flow, and I quickly tried to find one in Python to explain it, but I didn't find it. I'm sure it exists. You can look it up. All this code's online, so if you are interested in something similar, you can refer to that. And at the end, each container summarizes this data into a compressed JSON-L file. I use this instead of CSVs because it's just much easier to serialize from your program. You can have a much richer structure, so you can have sub-fields, sub-documents, and you can change it over time, and it doesn't break as quickly as if you're using CSV. And a lot of the new platforms support it too. So statistics for my collection, about every day we read in about 2 gigabytes just of text, so we don't load any of the JavaScript or the images, so it's a fair bit just in text. We send 4,000 requests. 94% end up falling back to using the proxies. That's about 30 requests per second, and it takes about 30 to 50 minutes to complete. Most of the costs for running this come from those proxies and the warehouse, depending on how much we use it. So the first step when we actually, to do the study, we needed to work out which channels to look at. So we were considering any channel that had more than 10,000 subscribers and had a focus on United States politics or cultural commentary, approximately like more than 30% of their content focused on that. And to discover channels, we started with an objective criteria, like starting from the official lists or tags for news, and then finding recommendations. But we found it was difficult. It was having a lot of false positives and also missing a lot of obvious channels that should have got. So we actually just adopted a variety of strategies. So looking at other research, looking at things like Social Blade, and following the recommendations that YouTube made to get the most coverage we could. So we try to, it's hard to gauge how much we have of all of the channels that might meet the criteria, but we think we've got most of them. And then we classified them. So to do that, we had 3 viewers go through every channel, about 800 of them, watch their content, and then categorize them in a variety of ways independently. So one way we categorized them was either left, center, or right. The channels that were fairly mainstream news would be listed on 2 websites, Media Bias Fact Check or Ad Fontes Media. And if they were in those, we would just take the majority view from those 2 sites. If they weren't, we had more subjective criteria that people went through. Then people classified them with, up to 4 what we're calling soft tags, which are properties about the channels we think are relevant. So things like, are they state-funded? And what is their ideology? Are they libertarians, conspiracy theorists, social people promoting social justice, things like that. And then from that, we took the majority view from all of our reviewers, analyzed how reliable they were, and we derived a group, which is simple one-to-one category with channels that, so the tags were optimized for reviewers, classifying content very concretely and specifically. And this group is more to fit into public discussion about ideology and YouTube. So you can look at the details of that in the study or on GitHub. And the results were, in terms of the categories, on the left, we're showing the relevant daily views between those different groups that we categorized. At the top, center left, mainstream media, partisan left media, and partisan right, and then smaller groups. And on the right, you can see the total amount of channels. And it's interesting, they don't correlate. So a lot of the smaller groups have a lot of channels, which just represents the supply of content that's on YouTube. I think people get confused when they talk about the proliferation of different groups on YouTube. They often ignore the amount of views and concentrate on the amount of content. So I'm going to show our visualization. This is public. You can go to recfluence.net to have a look at it. And it shows an overview of what we've done. So each bubble here is a channel. The size is the number of daily views that channel gets. And they're positioned according to physics, basically. So it's called a force-directed graph. And each channel repels each other by default. And then they're attracted to each other by the percentage of recommendations between them. So channels close to each other have a lot of mutual recommendations. So you can't rely on the axis, like left, right, up, down doesn't mean anything. And each time you update the data, it will look quite different. But the distance between the channels basically remain similar when you do that. And on the right, we're showing the flows of impressions between them. So we're calling an impression when you see a recommendation or a video, this is the amount of views for that video converted into impressions of that. And on the right is where they're going to. So where the groups that recommendation goes to. So as an example to understand this, CNN, you can see the lines here highlighting where CNN's recommendations go to and come from. And on the right is a summary of those flows. And then in the chart, if you want to change between different ways of splitting this up, you can do that. And you can highlight groups. So here I'm looking at conspiracy theories. And if you zoom in, you can see exactly what channels they are. Largest being the Next News Network and Paul Joseph Watson, both promoting things like 9/11 being a government conspiracy. So back to our analysis, this shows simply the recommendations from the groups as a percentage of all the recommendations to other groups. I'll just point out a few patterns. You can see the diagonal line from the top left to the bottom right, and that's basically the bubbles that people are in. So if you're watching a center left NSM video, 51% of the recommendations is to other ones in that group. It's an open question whether that's more bubbly than traditional media, but it's definitely exists. The other pattern to look at would be the provocative anti-SJW conspiracy theorists, religious conservatives, and libertarians, the percentage of their recommendations that go to the partisan right stands out. And then along the column, the conspiracy groups, the socialists, white identitarian MRAs, you can see they're very much blank. So they're not getting many recommendations from the other groups. So this is a very simple and easy to understand way of presenting this data. But when you think about what a neutral algorithm would look like, it would be one that recommends channels proportional to the views that it already gets. So it has very little influence. And that would look like the bigger groups are more bubbly, or that the smaller groups are being disadvantaged, when that's not actually the case. So we analyzed, to solve that problem, we analyzed using what we're calling net impressions. And this is how we get to there. So every day we collect recommendations and new stats for videos so we can work out how many views are on a video on a particular day. So I'll give you a really simple example. I got video A with 5,000 views for the 28th, and it's presenting video BCD. So we give those 5,000 views as impressions towards the other videos. So we count that as a sending an impression from video A. And out of those other videos, video B is the only one that has an impression back to our video A, but it has 30,000 views. So we're saying that A receives 30,000 impressions. So from that, if this was our entire data set, we would say that video A sent 15, received 30K impressions, which is a net of 15,000 received. And that's an impression advantage of 100%. So that's clear. And that is the context for this chart, which shows the way Google tips the scales to sort of who they advantage and who they disadvantage from these groups. So we can see center left MSM, although it's got the most amount of views, it's neither advantage or disadvantage in November, December, which this data is for. But partisan left and right are advantaged by the algorithm. And then mostly the other groups are disadvantaged. In particular, the borderline content and conspiracy theorists get hardly any views anymore. And here I've got an animation over time. So this is all our data we have. It's a little bit noisy. But you can see in about, as it's cycling through, probably focus on conspiracy theorists. In April, it really starts to change. So we're getting too late. So this is the beginning of the data set. Conspiracy theorists about getting equal to the views. And then it starts being neutral, and Google started limiting it by April, and then even more so as time goes on. So we there was other ways to split out this data. We looked at the left-right bias, and they're fairly neutral in that respect. So they're not benefiting one side of that spectrum or the other. But there's a large mainstream bias. So mainstream media receives 22% extra, and independent YouTube channels are severely disadvantaged. Missing link media, a little bit disadvantaged. Missing link media is just for-profit, relatively mainstream, but not quite channels. So this is in detail the flows between each group to each other. I won't go through that, but I've summarized all of this, which is more than 1 million net flow per day. So you can see that social justice channels are losing a lot of impressions towards center left, mainstream media, or the partisan left. And the more borderline or smaller groups that are, we might consider right wing, go towards the partisan right, leaking a bit to the left in the mainstream media. is quite different to the story that, or common knowledge about the way the algorithm's influencing views on YouTube. And there's a certain story that I think this debunks. So the story goes like this. There's a rabbit hole on YouTube. To increase revenue and keep you watching, YouTube recommends increasingly extreme content. This is how they have you believe as many possible things before breakfast. And this is kind of intuitive for most people, I think, because when you come from reading the newspaper or watching cable news or TV, there is a much more diverse amount of quality, and also the spectrum of politics. There's some really weird stuff as well. So that stands out to people. But the claim goes well beyond that. It's that it's giving you increasingly extreme content broadly. And I think that's false. And I think the journalism has been biased in this area. So I think part of it is an anti-tech bias. The technology companies have taken most of the advertising revenue from media. And at the same time, people's information diets are much more decentralized now. And media are trying to keep their influence by decreasing the status, by disparaging them. I think the other effect is just selection effects. The most shill people about the dangers of technology get the most attention and the most shareable information about it. And from journalism, so from research, I think there are similar effects. I'll give you some examples. The peer-reviewed research in this area will describe viewers that move towards the far right as being infected, these language like that. When they look at radicalization pathways, they only look at it towards right wing. They don't look at the other way. And they only look for evidence of that. So they'll look for recommendations towards right-wing channels, but not from right-wing channels to left-wing, or not from extreme right-wing to less extreme ones. So it definitely seems like everyone's trying to confirm their existing beliefs. There's not enough curious research about what is actually happening and then reporting on that as well. One of the main criticisms of what we did was that we use anonymous data to collect. So when you get recommendations, they're personalized. So things like the location that you're from and your history, your viewing history, and other things are taken into account. So not everyone's will be different. The reason everyone would like to do this in this area, but it's very difficult. So there's two reasonable ways to try and get at this. You could simulate prototypical users, try and get like a representative sample of real, like sock puppet Google accounts that have had a history similar to different types of people and those representative people in the United States, and then look at the recommendations that they get. But that really entails a lot of work and also a lot of assumptions about what those users would be, what their history would be, and whether that's representative. The other way would be you can get people to install browser extensions and then record what they actually see from the recommendations from their real YouTube viewing. The problem with that is it's very difficult to get people to install something like that and be willing to send you all the information over a large period of time. It would be difficult also to make that representative. So our working assumption is that personalization will average out. So because even though it's personalized for different users, unless they're really tilting the scales in some weird way or changing the algorithm with personalization, it should be about the same. So given that what they're showing you is the average of views to what's popular for what you're watching now, So I'm explaining this really badly, but you get the idea. It should average out, and the way we're working to try and see whether that is the case is we're comparing creators' private analytics. So if you're a creator of videos on YouTube, you can actually see the other channels that are recommending you, and you get the real impressions, the amount of time people have actually seen the video. So if we can get a large enough amount of creators to send us this, we should be able to get an idea if it is the same, or if there are systematic differences, what they are, and try and take that into account. But as it stands now, we see a lot of correlation. So when we saw the change in recommendations to conspiracy videos, we then saw those creators complaining about the same thing. Lots of other things that happened over time as corresponded. So consider this the most comprehensive study so far, and it's still an open question as to whether that assumption is correct. So all of the code I've licensed as an MRT license, so you can use it whatever you wish. Aggregated data you can download. If you want the full data, you just need a Snowflake account, and then I'll share that with you, and you'll get updated daily statistics. The reason why I can't share that with files, I'm not sharing with files, because it's up to about 40 gigs, and it's just not practical. And you also want the latest, so I'm not trying to hide it from you. It's just you ought to use a database. And I'm looking for grants and collaboration. I've really enjoyed working as an independent researcher for a tiny amount of time. And, if I don't get money, I'll continue running it, but I'm going back to my normal job. So definitely reach out if you want to see, or if you know someone that will want to see more of the type of research we've done. So that's the end of my slides. Open up to questions. Happy to do demos of anything, so Tableau or how we classify things, or looking more at the visualization, anything.
You had one slide that was a matrix of the groups that was percent recommendations. And I noticed along the top, horizontally, on the very rightmost side, there was one group, non-political, but I didn't see them on the labels vertically. And I was just wondering, I was kind of interested in the non-political groups, and in particular, if you knew a news source that was non-political.
Okay, the question was, there was a non-political on the horizontal axis, but not on the vertical.
On the slide that was percent recommendations.
Yeah.
Yeah.
So in terms of our data collection, it's just unfeasible to collect all of the recommendations from all of the channels on YouTube. So we only collect the recommendations from the political channels in our data set. So we don't know what recommendations are coming from channels outside the data set, but we know ones that are going outside from within. Does that make sense?
Not really, but really what I'm interested in is, did you find YouTube channels about news that were non-political, and what were they?
A non-political YouTube news channel.
Is that what this last column is for?
No. It's a non-political channel.
What?
Non-political channel, right?
Yes. Yeah, that's right. So it's a channel that's outside our data set. So we haven't got in our list of political channels. So it could be a music video. It could be cooking. I don't know.
Okay.
I haven't actually looked at what the non-political
Okay, so
we've looked at that list to try and find extra political videos. We haven't summarized which type of channels they were.
Okay.
Okay. Any other questions? He's now trying to give you a question.
Yeah. So this isn't a technical question, but I was just wondering whether you have any thoughts about what the Facebook recommendation algorithm would be based on what you've learned about the YouTube one? Because obviously, like, there's been a lot of news about Facebook influencing elections more so than YouTube.
The question is about Facebook. Have you looked at Facebook recommendations?
Or just like your thoughts about it?
We haven't. I can speculate. It's slightly different on Facebook because you've got your news feed and they're deciding what appears to you. I think, I'm actually going to speculate, so I don't actually know very much. We've really focused just on YouTube.
So I'm not much of a YouTube user, but I gather that people who are logged in aggregate recommendations which are personalized to them based on their other viewing. These are all predefined channels, am I right? Or
yes,
I see. But how does the recommendation algorithm work for individuals that watch content? Does it put them in a bubble which is similar to the stuff that they ordinarily watch? Or does it throw in a little serendipity just to give them a little diversity? Or does it categorize them and lump them into one of these categories that's the closest to what they appear to be watching? Did you look at any of that? Did you, create personas for any of your people that, create personas for any of your channels that might suggest how people get led if they watch certain kinds of content?
We didn't do that systematically because of the difficulties involved and the assumptions that we'd have to make. But we did do a few experiments. So we created a fresh account and looked at conspiracy videos just to do a sanity check to see whether that personalization would mean you get conspiracy recommendations that we weren't seeing when using anonymous, and they didn't. But apart from that, no, we haven't done any systematic look while a user's logged in. But looking at the way other recommendation system works, personalization works, you can guess, my assumptions are that it's a lot to do with what you've previously watched. But there'll be, because the anonymous recommendations of what people have organically watched, you'll have both sides of the direction of influence taken into account with the average anonymous recommendations. So that personalization should skew fairly evenly both ways, is what we're assuming.
And another question, I assume they use popularity or recency as among the things that cause them to recommend something. Is that true?
That's true. Yes, that's true. Okay. That's what Pew found. That's what they say they do. That's what we found.
It's vaguely interesting to me that you didn't assume that they would try to maximize staying on YouTube as long as possible. As an advertising company.
Yeah, well, we think that they do. We assume that they try to get people to stay on YouTube, but we don't think that they're recommending consistently extreme content to get you to do that. They're recommending you content that they think you will like the most. So there was a form of the algorithm probably before we started, which was based on more on the click-throughs for recommendations, which is quite prone to clickbait. But these days, the algorithm's based on another combination of metrics, how much you watched the video you clicked on, and then they give out surveys. So it's also based on how much those people liked the videos that they watched. So they've gone a more holistic approach now that looks at, are you going to enjoy the next video you watched? Which is to get advertising revenue, but it's not as nefarious, I think, as what the common stories about it are.
So my question is whether or not you've done any analysis regarding like a bias towards U.S. news or away from U.S. news, or if the data collection prevents that analysis.
We just looked at US news, so we don't really know the differences between them. I think a good way to take this, if we can find people to collaborate, is to look at other countries like Brazil and maybe Portugal, where it's a big impact. In Australia, I don't think much of our politics is on YouTube. For whatever reason, we consume your politics.
So I'll just try asking this one more time. I didn't ask correctly before or explain it very well. I was just wondering, did you find any news groups that are nonpartisan news? Does that even exist?
Didn't look for them. They weren't interesting. That wasn't his goal.
Oh.
There are some, but there's not as many as you would expect. Just from my experience, I like PBS NewsHour. That's pretty neutral and good. But most skews one way or another. Like, I think maybe the idea that you can be that neutral is a bit naive.
Hello. I'm just curious how you order the axis and the ordinates. Why aren't they strictly, why isn't this graph symmetrical? Given you have the same ordinates and axis on the same thing, and then why wouldn't you have the highest numbers in the upper left and going monotonically down to the lower right?
That's a good question. It's because it's the percent of total of the left group that makes it asymmetrical. Does that make sense?
That sounds like a bias to me.
So if you add up the percentages across the rows, it should be about 100. But that means you don't get a symmetrical chart. But it makes sense in terms, it's the best way, I think, to display, to get a sense of the percent of recommendations from each group. And then the other chart's symmetrical because we're looking at the total flows of net recommendations.
Makes sense.
Cool. Any others? Okay, well, thank you very much. It was an experiment.